This lesson introduces you to a simple class that will read a graphics file from disk and store it in memory. The memory resident form of a graphic image is held inside an object of the image class. The image loader class extends the component class. The reason it needs to extend the component class is because it implements an interface named image observer, which requires the presence of a method that tracks the loading of an image into memory, and that method exists in the component class. Now, this class has no main method and no constructor. It's a utility class with one public method, load image from file. This method is given the name of a graphics file and returns an image object containing the graphic information from that file. The toolkit class has a static method named getDefaultToolkit that returns the address of the default toolkit object. The toolkit class is the basis of the abstract windowing toolkit and contains many of the low-level operations, and you usually don't have to use it. One of the low-level operations that does come in handy is the getImage method that loads a graphics file into an image object. Well, it doesn't exactly load the image. It schedules the loading of the image and then returns to its caller. When getImage returns, the file is not yet loaded. This means that the program could go on about its business and check back later to see if the file is loaded. But in this example, we just want to wait for the image to load. This method is here just to wait for the image. A media tracker object is created to do the waiting for us. Notice the argument to the media tracker constructor. This is a Java keyword, and it's the way an object refers to itself. You know, when you want to refer to an object, you use the name of the reference holding its address. Well, the keyword this is the name of an object's own reference. The constructor of media tracker requires a component object be passed to it, and this is a component object. In fact, that's the only reason this class extends the component class. If this code were inside a canvas or a frame class, it would work just as well because they're also components. Now, the media tracker can be given a collection of images, one image at a time, and it will track their status. The way to add an image to the list of those being tracked is to call addImage as we do here. Notice the second argument. That's an ID number. If you're going to be loading lots and lots of images, you can assign ID numbers to them and wait for them all to come up according to the ID numbers. The ID numbers will put them in groups. In this example, we're not going to do that. We're just going to add one image to the list and wait for it to load. A call to the method waitForAll will not return until all images are completely loaded. So we call the method, and when it returns, the image has been completely loaded and is ready to be displayed. But I'm sure you noticed this little thing here. The try and catch statements are part of the Java error handling system, and I'll be going into more detail on that later, but for right now, let me just give you a quick overview of what's happening here. The waitForAll method could encounter an error while trying to load an image. It could be that the file is corrupt, or it doesn't exist, or whatever. But whenever you are dealing with input or output, things are going to go wrong. If such an error does occur, then the waitForAll method will throw an exception. What this means is that waitForAll will construct an exception object explaining the situation, then it will throw the exception object to its caller. When it throws this exception, it abandons all processing at that point and returns to this method. That's where the catch comes in. If an exception of the type specified in the catch statement is thrown, then the code inside the catch block will be executed. In this example, a method of the exception object is called to print out some information about what has taken place, and then system exit is called to end the program. However, if everything goes right and the image loads, this method will return with a fully loaded image, and that image is then returned to the original caller. In the next lesson, we'll use this image loader class to load an image, and then we'll display it in a Canvas window.